convenience and just see if I could do it. And I did do it, and there it is. So if somebody could click on it, I don't want to click on it because I'm already in My Labs Plus. Somebody can click on it and tell me if it works. I'd appreciate it.
Oh, I clicked on it last night when I saw it. It did
Okay.
work.
It did work. Good. Well, that way you don't have to go to another window, and you don't have to go to Blackboard, which is usually down anyway. So it really doesn't matter. So anyway, make a long story short, let's go to our first question. We got 2 questions sent in. I looked, I didn't see any, but I saw 2. That's all I saw. So let me look and see if this is one. No. Okay. Just making sure I didn't miss a question. All right, so this is 5.1. Now, when I pull up a question, it's going to have this number right there. That's the number in the book. So if you've got a book handy, or you printed out your book, or you got it online, look at 5.1 in the homework section of the book, and look at number 57, and it will look like this question I'm fixing to pull up. So that's the book number. And this is the homework number. So this looks like everybody's homework question 16. So maybe a different number, maybe look a little different, but it'll be the same type question. So when I pull up a homework question, I'll say 5.1 69/19. 69 is in the book, 19 is online. Everybody got that? So I don't have to say it 15 times in the future. All right, so this first question is 5.1 57/16. And I tell you if it's a test question or not first. That's the first thing I tell you. And this one is not a test question. This is a homework question. I would never put this on a test because it's kind of dorky, okay? But they're trying to show you the application for the prime factorization. So that's what they're showing you. Now you could do this in your head if you wanted to, but what they're trying to show you is this is the application for da 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 da. Okay, so here's my handy dandy Word document or document cam. Let's set that resolution at 1040. And there we go. So first thing we're going to do is we're going to write down 120 because 120 is what was I want. We 120 right here, 120, and we're going to prime factor that 120. Prime factor 120. So 120, 2, 3, 5, 7, 11, and sometimes 13. All right, now I want you to take a second. I want you to break that up into prime factors. Shouldn't take long. So I'll give you a second. Okay, Miss Hatton's trying to get in. Evidently, hold on, Miss Hatton. I knew we were missing somebody. Hatten. Okay, answer the phone. That's my phone going off. Miss Hatton, no, she's just calling her. Okay, so Miss Hatton is not in yet. So let's see if she comes in All right, so everybody looks at my mouse and say, good God, that mouse has been through it. I've had this mouse for I don't know how long. And I'm a mouse person. I don't care nothing about the thing that's on the mouse pad. I hate mouse pads. I use them, but I don't like them. Miss Hatton, did you come in? There she is. Miss Hatton, you there?
Yeah, I'm in now.
What happened?
I don't know. That thing be acting crazy sometimes.
It's the Russians. That's what it is.
The Russians.
Yeah, it's the Russians. All right, so 2, we're doing a homework question. Homework question, the one we're doing is number 57 in the book /16 online. So
Okay.
we're doing your homework question number 16 or everybody else's. It looks like this question. Okay, now I got to get back to it. There we go. And there we go. And 2 will go into 120 60 times. 2 will go into 30 times. 2 will go in 15. 3 will go in 5. And 5 will go in 1. And there is your prime factorization. So your prime factorization is 2 times 2 times 2 times 3 times 5. Now, most of you, 95% of you will get to that point, but you don't understand what the question is asking. What the question is asking is saying that you got a room and you got to have at least 2 chairs in each row, at least. That means the lowest number is 2. So what you do is you take this 2 right here and you multiply by what's left.
Priority 1 message coming
and that's going to be 2 times, well, this is going to be 10 times, that's going to be 60. So that's one setup. Now you can't do 2 times 60, 2 times 60, and 2 times 60. Okay, so the 2's are out. Then you go, okay, well, what about the 3? So we go 2 times 2 times 2 times 3 times 5. So let's hold the 3 because 3 is at least 2, isn't it? Yes. So there's 3 chairs in a row. And what's left? Well, that's 8 times 5. That's 3 times 40. Okay, so we use the, I'm going to take my highlighter out because y'all know I like to write in highlighter. So here we use the 2, which basically covers that 2 and that 2 also. Here we covered a 3. So the only number left that's prime is 5. So 2 times 2 times 2 times 3 times 5. And what's that 5 going to be multiplied by? 24? And that takes care of the 5. Now, the overlap counts on this one. So 2 times 60 means 60 rows of 2, or you can have 2 rows of what? You can have 2 rows of 60, or you can have 60 rows of what? 2. You can have 3 rows of 40, or 40 rows of what? 3. And you can have 5 rows of, or 24 rows of 5, or you can have 24 rows of 5, 24 rows of 5, or you can have 5 rows of 24. Now there's one other number we haven't seen. Well, technically there's 2 other numbers. Let's see. There's 10, okay, 10, 5 times 2. So I'm going to go to the next page. I'm going to go down here, and I'm going to write 2 times 2 times 2 times 3 times 5. And I'm going to circle these 2. And that's 10. So 10 times what? What's left? 4 times 3 is 20. I'm sorry, 12. So I can have 10 rows of 12, or I can have 12 rows of what? 10. And we can do the 15 right here. So I'm going to write down 2 times 2 times 2 times 3 times 5. 15 times 8, or 8 times 15. 15 times 8, or 8 times 15. And I think that will pretty much do it, because then you start lapping back around and going, well, 3 times 2 is 6. Well, we could do 6 times 20. We got that. I thought we did. No. So we do 6 times 20, or what? 20 times 6. And after that one, you pretty much are overlapping because of the repeating 2's. So that should be your answer. So the problem is just this. And then this is different arrangements of, let me get my green highlighter out. These right here are just different arrangements of your prime factorization. Here, I made the 2 dominant. Here, I made the 3 dominant. Here, I made the 5 dominant. Here, I made the 10 dominant. And the reason I changed colors is because these are composite. But in a case of rows and columns, you don't have to stick with the primes, okay? Here is... I
think we're missing the 4.
Okay, thank you. 4 times 30, there it is. No, okay, yeah, thank you. And the 2 4's right here, the 4 times 30, so that would be 4 times 30 and 30 times 4. Thank you. So it's just different arrangements of the numbers. Does everybody understand that? Hopefully you understand that. This is a homework problem. This is not a test question. Like I said, the reason I wouldn't put this on a test is one reason it takes too long for one problem. I only want you to take a problem. I want you to do it in a couple of minutes. This problem will take you about 3 to 5 minutes to do because of all the different arrangements. Now, could you have done this in your head? Yes, you could have, but it'd get all clogged up. That's why you need to kind of have this right here to help you do the problem. Okay? Question. Hope that helps. Okay, next one. Oh, let's, where is my homework? There we go. And this question is 5.1 69/19. This one shouldn't even be in the homework, much less a test question. It shouldn't even be in the homework. This one is, okay, I don't like this problem, and if I could ever remember to take it out before homework, I would, but I always forget. Okay, somewhere in your book, go ahead and write the problem down. It's only a sentence. Okay, so this is somewhere in the book. It should give you the equation for Fermat's theorem. And this for Fermat's theorem is basically 2 to the second to the n power plus 1. Now, there's no way in Hades that you're going to know that unless somebody gives it to you. And I really don't understand why this question is in this section, because there's no application to what we're doing except the numbers come out to be prime. That's it. So this is really not a good homework problem, and it sure is not a good test problem. So I would not lose any sleep if you don't understand how to do it. I'm going to show you how to do it. You do it, you get your points, and you keep going. I would much rather you worry about doing a problem with least common multiple, greatest common divisor than doing this problem. All right, so I want you to plug in 1, 2, and 3 because they're asking for the first 3 numbers. So that's going to be 2 to the 2 to the 1 power plus 1, 2 to the 2 to the 2nd power plus 1, and 2 to the 2 to the 3rd power plus 1. Now you may need a calculator for the 3rd one because it's kind of a big number. So let's go to the first one. N is equal to 1, N is equal to 2, N is equal to 3. All right, 2 to the 2nd power plus 1, 2 to the 4th power plus 1, and 2, let's see, 2 times 2 times 2 is 8th power plus 1. Now 2 to the 2nd power is 4, 4 plus 1 is 5. 2 to the 4th power is 16. 16 plus 1 is 17. 2 to the 8th power is a big number. I think I got it at 256. So that would be 257. And those are your answers. Now, like I said, you don't have to understand it. The problem is not a good problem for this section. Yeah, they're all 3 prime. That's about the only application that these 3 numbers, that this question has to this section. I really disagree with the placement of this question. So that's it. That's how you do it. Hopefully that helps you. And the only reason I'm doing it is so you can get the points. I'm not doing it so you can understand it because there is no application for it. Okay? Okay, that's the homework questions for today. Now, that means that everybody in the room should be able to finish 5.1 homework now because you've had today to send me questions. Now, who probably have not sent me questions? The ones that haven't what? The ones that haven't done the homework. And you're going to try to send me 5.1 questions when I'm in 5.2 and 5.3, and we're going to have a prayer meeting. Okay? And everybody knows what prayer meeting's about. We're going to discuss it. All right. So with that being said, we're going to move on to 5.2 now. Let me delete those 2. And this is how you keep up with my class. I'm going into 5.2 today. Whatever I cover in 5.2, you're responsible for. If I finish 5.2, then you're responsible for 5.2 homework to be close to finished by Friday and homework questions for 5.2 to be sent in to me so I can answer them Friday so you can have 5.2 finished by the weekend. That's how this works. But the problem is we get some students that want to wait till the test to do the homework, and that's where we have problems. That's where everybody that's where things start breaking down. All right, so here we go. Let's go to our handy dandy class and pull up the e-text. And let's look at the problems that we're going to be doing. I think it's signed numbers. I'm pretty sure it's integers, but I'm going to look and make sure. And of course, all of us know signed numbers are not that difficult unless you have somebody giving you a bunch of rules, and I'm waiting on it to come up. Okay, so 5.2. Yep, integers. I'm not going to look at the book because I'm not going to use their rules. So we're just going to go straight to the document cam. And we're going to talk about the two difficult ones first. And that is adding and subtracting integers. Integers are signed whole numbers. I mean, basically positive, negative whole numbers. Well, actually, they work with all numbers because when you add and subtracting integers, that means positives and negatives. You could have positive and negative decimals. You can have positive or negative fractions. So you can have that. So they're basically signed numbers. When you're adding and subtracting signed integers or signed numbers, you got to remember money. All you got to remember is 3 rules with money. 3 rules. 1, when you have a plus, that means you have money. When you have a negative, that means you owe money. And when you have 2 signs together, it makes a positive. 2 signs together, and I mean they're right beside each other. That's the 3 rules you have to remember. So if I give you -2 plus a -4, that means I owe $2 and I owe $4. If you owe somebody $2 and you owe somebody $4, you owe them $6. Well, Hubert, they ain't all like that. Okay, well, let's do another one. 4 minus 6. This right here is positive because there's nothing there. So that means you have $4 and you owe $6. Well, what's the outcome of having $4 and owing $6? You owe $2. Now, I can't speak for the guys because guys are kind of slow. But when it comes to money, Miss Hatton, tell me something. Can you shortchange a woman?
No, ma'am.
No. I used to work at Walmart before my Marine Corps days, and I'd be at the counter during the Christmas time. We would shut down the sporting goods, and we'd have to go up to the front to be cashiers. You know, back when Walmart had cashiers, and I would accidentally make a mistake. To a man, he wouldn't even notice. If I accidentally made a mistake with change with a woman, a nanosecond. And she would go, whoa, wait a minute. I mean, it would be a nanosecond. Okay? When it comes to money, if you associate this with money, you won't ever have another problem. Let's do a nerd. How about 4 plus 8. Well, that's pretty simple. You have $4. You have $8. You have $12. And then the one that causes all the problems, 4 minus a negative 2. Well, remember I told you, if you have two signs close together, what do you turn them into? Turn it into a positive. And that gives us, you have $4 and you have $2. You have $6. And that's it. I mean, I do not understand why people make integers difficult. Teachers, I mean. I don't know why they make it difficult. But that's it. Anybody got a example of one that's hard to do? I'm trying to think of one.
No, but I have a way to make it a lot easier for people.
I'm sorry, what?
I said I don't have a question, but I have the way to make it a lot easier for people to like understand.
He's breaking up. Did somebody hear what he said? I'm sorry, you broke up and I couldn't hear you, Mr. Hubbard.
Can you hear me now?
Yeah, now I can hear you. What'd you do?
I just picked up my computer.
Oh, okay, good. All right, what did you say?
I said I have an easier way for people to understand that.
Yeah, I mean, that's easy to understand this way.
Yeah, no, I have another way. Like,
oh, how is it?
It's called KCC, keep, change, change. So like the first number, so like that 4 is a positive, you would keep it a positive, keep, and then that negative in the middle, you change to a positive, and then you change the negative 2 to a positive. Keep, change, so it's 6.
Okay. Yeah, I can see how that can be simple. Good. And if it works, you keep doing it. Okay. This is the way a lot of people say, well, where'd you come up with this? Well, I came up with this when I was a student at Tri-County Tech. Now, I'm not saying that I came up with the money thing. I'm not saying that. I started using it. How about that? Because I know somebody probably thought of this before I did, but I started using this when I was in like math -31 when I was at Tri-County Tech. And some of y'all that had remedial math know what I'm talking about. I was in the negative math. All right, I was in, it was called Math Essentials. And that's when I started using the money because it works. And if you do -3 plus 4 minus 7, well, this means you owe $3. This means you have $4, and this means you owe $7. So if I owe $3 and I have $1, that means I still have $1. If I have 1 and I owe 7, then what does that mean? I still owe what? 6. And you can do these all day long as you do those 3 rules. 3 rules are: 1, positive means have. 2, negative means owe. 3, if you have 2 signs together and there's nothing between them like a number, then you change that to a positive. But I think that's what you were saying, Mr. Hubbard. Keep, change, keep. Yeah, I can understand that.
Yeah, that only works with 2 numbers though. When you do the 3 numbers, that's super irrelevant. So
yeah. Okay, well, you can always fall back on the number, on the dollar sign. How about that? Okay. Anybody got a question on that? Because these are, like I say, these are the ones that give people a hard time. Now, when you put the fractions with it, that's where we get into 5.3. So let's go ahead and move on to multiplying and dividing. And this is easy to remember because jumper cables. Like signs are positive. Unlike are negative. When you hook up jumper cables to a car, you better make sure that that red one goes on positive and that other red one goes on positive. Because if you mix the two, you're going to have problems. Okay? There's a red pair of jumper cables and there's a black pair. Okay? Y'all like that, don't you? That's animation. Okay. The red pair goes to the positive. Actually, it doesn't matter as long as you keep them the same. It doesn't matter how you hook them up. The black pair goes to negative. And if you hook up the black pair and the red pair correctly, there is no problem. You start the car up and it keeps going. But if you cross the negative with the positive, and you cross this negative and you have mix match, you're going to blow the alternator and the battery up. And it'll be like a welding machine. It'll turn everything red, orange, because it's getting so hot. Okay? So when you hook up a pair of jumper cables, you look on the battery and you look for the positive and negative symbol beside the post, and you make sure you hook up the positive to positive and negative to negative. And if you do it that way, there's not any problem. Like signs. Positive, positive, good. Negative, negative, good. Unlike dang old blow up, dang old alternator. That's bad. So that's how I help students remember like and unlike. So positive 3 times negative 6. Well, that's unlike signs. So your answer is going to be negative, and 3 times 6 is 18. 4 divided by negative 2 is equal to negative, and then 4 divided by 2 is 2. 3 times 8. Well, they're both like signs, positive 3 and positive 8. The answer is going to be positive 24. Now, of course, you don't have to put the positive. I just put that to show you that we have like signs. And negative 3 times negative 3 is equal to positive 9, like signs. And that's how you do division and multiplication. Now, the reason I'm not spending a lot of time on multiplication and division is because everybody in this room should be pretty aware of like and unlike. I understand if you always have problems with this. Yeah, I understand that. But this right here, everybody should be saying to themselves, oh yeah, I don't have a problem with that, with multiplication and division. I don't have a problem with that. My problem is with when you add those guys. That's where the problem is. And I can understand that. Okay. Now, basically, that is 5.2. Now, looking at my clock, it does say that, okay, we got a few minutes. We got about 10 minutes. So we already called the roll. So I'm going to go ahead and look at some of the problems and I'll just go, oh, I forgot. Somebody asked me before class, show me how to do the review again, or show me how to go use in other words, if I don't understand something, how do I figure out how to do it when I'm at home by myself?
Priority 1 message coming in on secure channel.
This is how you do it. You go to, let's find, okay, course home. Okay, why is it? Okay, I'm getting out of that. There it is. I'm sorry. I thought I was at course home right here.
Priority 1
Let's say that
channel.
you have a problem with let's say 5.1. And let's go to And you can't do a problem in 5.1. Let's find a problem. 5.1 homework. I'm going to go find a problem so I can show you how to do it. And let's say that you understand how to do it, but you want to do a couple more problems. Okay? Let me find a. They wanted me to show you how to do this again because they forgot how to do it. Okay, here is a problem right here that I would put on a test. And I told y'all that these are the type I put on a test. And you say, okay, that's 5.137. So you would write that down, 5.137. And then you'd look at the next problem and say, okay, that's the same type. So 42. And you're trying to find the same type of problem. Okay. So 37 and 42 is the same type problem, but I want to do more problems. Now you can do that by answering it and saying the prime factorization of 42 is, let's see, that'd be 6 times 7, which would be 2 times 3 times 47 times 7. So I'm going to type in, I'm going to do the answer, and I'm going to say 2 times 3 times 47 times 7. And next question, I thought it gave you another chance to, yeah, right here. After you answer that question and it's right, you can hit similar question and it'll regenerate another problem for you. That's one way to do it, okay? The second way to do it is to go to chapter contents, and I want to go to chapter 5, because in 1, that's 5.1 homework. And then go to study plan. And that will give you extra problems with no penalty, extra problems. Now you had to hit all this stuff again. I don't know why it does that. And you're going to focus on 37 and 39 and 41 and 42, because those are the numbers. You wrote down 37 and 42. Well, there's 2 that's not even on the homework, 39 and 41. So you got 4 problems there that you can work on. Now, let's say you do this, let's do 39, and you get on there and you go, golly, this is a hard one. I don't know how to do this one. Well, then you send it to Hubert. Ask my instructor. Okay? So that's how you utilize the extra problems. And hopefully that'll help for the person that asked that, because they couldn't remember how to get to the chapter content or the study plan. It's called study plan. And that's just extra problems. And you find the problem that you were on in the homework. In our case, it was 37 and 42, but we got 2 extra problems there that we haven't even seen. So you would do all 4 of those, and that would help you support or reinforce what you learned on 37 and 42. Capiche? Yeah, Hubert, we understand. Good. Now let's look at 5.3. I'm only going to discuss a little bit because I know what 5.3 is. 5.3 is fractions. And this is where everybody sucks. Adding and subtracting fractions. But you're not going to suck now, because why? Because now you know how to find the common denominator. Adding and subtracting fractions. And I show it first because that's what everybody sucks at. In order to add or subtract fractions, you've got to have a common denominator. And the common denominator is basically the lowest common multiple that we learned how to do in 5.1. I'm going to give you a quick example. Of course, I know you're going to know what the common denominator in your head, but it's a basic example, but I'm going to show you how to find the the common denominator. I'm going to go with 1/2 plus 3 over 24. Okay, that's the problem. Now, a lot of you would say, well, the common denominator is 48. Well, you're wrong. It's not. And what you're going to do is you're going to go down here and you're going to say, okay, 2 and 24. Let's see, 2, 3, 5, 7, 11, and sometimes 13. 2 will go in there 1 time, 12 times. The real math stops. I don't care about the greatest common factor. So I'm going to put a 2 here. That'll come down as 1. That'll be a 6. 2 here. That'll come down as 1. That'll be a 3. And a 3, 1, and 1. We got our 1s. So this is the common denominator. 8 times 3 is 24. So 24 is your common denominator. So how many times will 2 go into 24? 12 times. 12 times 1 is 12. 24 will go into 24 1 time. 1 times 3 is 3. And that answer is 15 over 24. Now that is a basic problem. Okay, that's real basic. Now, if you'd done 48, you would have had bigger numbers, bigger calculations, and then you would have had to reduce at the very end. And sometimes people forget to reduce. So I can't talk to the people that invented math because nobody's going to change your mind. But the people that suck at fractions or the people that are rusty at fractions, if you listen to me and do what I tell you, you'll never get these wrong. No matter how big the numbers, no matter how many fractions. Because there's several on the test that I will ask you with 3 numbers. 1/3 plus 1/2 plus 3 over 27, or 3 over 28. And therefore you take 28, 2, 3, 28. And 2, 3, 5, 7, 11, and sometimes 13. 2, that'll come down as a 2, or 1, sorry. 1, that'll come down as a 3, and that'll be a 14. 3, that'll come down as a 1, that'll be a 1, that'll come down as a 14. 2, 1, 1, 7, 7, 1, 1, 1. Okay, so I got 4 times 7 is 28, and let's see, that's 28, I'm making sure. 28 times 3, 28 times 3 is 84. Somebody check me. What's 28 times 3? Somebody check me, please.
You're right.
And I think I said 84, right?
Yeah, you're
So
right.
here we go. 1 over 3 plus 1 over 2 plus 3 over 28. And I said 84, 84, and 84. And this is the trick right here that I love. How many times will 3 go into 84? Cover up the 3. 4 times 7 is 28. 28 times 1 is 28. How many times will 2 go into 84? Well, it's going to be 6. That'll be 42. 42 times 1 is 42. And 28, cover up the 4 and the 7. And that leaves 3 times. 3 times 3 is 9. And you notice I just did all 3 of those without any calculator at all, except for the 84. And I just asked y'all to check me. Okay? So 28 plus 42 is 70. 9 over 84. Lord, it's a miracle. I just did that problem without a calculator. Isn't that amazing? If you're shown how to do it you can do it. But what happens is people are not shown how to do this. I guarantee you there's somebody out there right now that has never seen this with a fraction. I guarantee you that you always were told to add them together or multiply them together or blah, blah, blah. This is how you do it. Okay? All right. Did I check the roll? I can't remember. Did I? Yeah, I did. Because there's supposed to be 10 coming to class, and we have 10. So the 3 people didn't show up because I knew there was 10 that showed up, and Miss Hatton was the 10th one. So I guess we're done. So I'm going to stop the recording right now, and I'm going to leave any questions to be asked after class. The rest of y'all can leave as you see fit.